Hello, everyone. We are from Huazhong University of Science and Technology in China, and we'd like to share our work, replaying styles for continual semantic segmentation across domains. Let's consider such a scenario: in an autonomous driving system, when encountering an unfamiliar geographic environment with unfamiliar targets to recognize, the system must adjust to the new environment while retaining its knowledge of the environments it has encountered previously. This necessitates the ability of the system to perform domain incremental learning. The model should have the ability to achieve satisfactory outcomes in a sequence of gradually arriving domains. Taking into account real scenarios, in our setting, we consider the incremental process include both label and domain shift in semantic segmentation. Simply fine-tuning the model in the current task leads to a severe performance drop. As the existence of both label and domain shift, we meet the challenge of catastrophic forgetting and distribution gap between different domains. To enhance the generalization and robustness, the existing incremental learning methods can be broadly categorized into three categories: replay-based, regularization-based, and parameter isolation methods. Among them, the replay-based methods have been extremely studied and have shown promising results. However, replay samples entail additional storage requirements, and the number of samples to be retained increases incrementally as new tasks are introduced, thereby exacerbating the storage burden of old task samples. How to replay previous knowledge with efficiency is an important topic to study. In our work, we notice the characteristics of low and deep level representations in CNN and leverage them to efficiently replay knowledge. While the fact that shallow networks are closer to the input, have a smaller perceptual field, and are more attuned to image details, thereby containing rich style information, deep network features contain more semantic information. Given that shallow and deep features are located at different levels in the network, a structural modification of the network is required to enable the fusion of domain-specific style features with the semantic features of input. Specifically, the original model is divided into three parts. H is the shallow module of the network for extracting style features, G is the intermediate layer of the model for extracting features that contain more semantic information, and F is the deep module of the network for fusing semantic and style features. We use the average style features of all input data for the kth task as the style features of the kth domain. Through feature fusion, we can obtain features of the current input in the past style. For each domain, we replay the low-level representation instead of samples as style feature, which can largely reduce storage overhead. Here is a comparison of our method and traditional replay-based methods. In the incremental sessions, we utilize the fused features to acquire and maintain knowledge of current and past domains with CE and distillation losses below. Based on the above analysis, the total loss of our work is denoted as below and the overall framework of our method is shown here. Here are some of our main experimental results. We conduct experiments on the cityscapes, BDD and IDD datasets, and set three incremental processes with different order. The data form cityscapes and BDD only has domain shift, while IDD has both label and domain shift with them. In each process, our method outperforms other compared methods. Furthermore, we compare the domain adaptation performance of MDL with our proposed method and find that our method outperforms MDL even when prior knowledge is added to the latter. Here are the visualization results after training on IDD in stream of cityscapes to BDD to IDD. Our method has a better segment performance on previous datasets. Besides, we conduct ablation studies on the impact of feature fusion and training loss, which suggests the role of each individual component. In conclusion, here are the main contributions of our work. Our proposed method involves extracting domain-specific styles from the shallow features of a network, which allows us to obtain style feature maps for different domains. Besides, we utilize fused features that incorporate different domain styles to augment the training process, which effectively mitigates the problem of catastrophic forgetting of previous domain knowledge by the model, thereby enhancing its robustness. In the future, we still want to explore some interesting questions remained. How to extract more appropriate style features, how to apply the method on the large pre-trained models and how to apply the method when training data is limited. Thank you for your attention.